Circuit breaker, what is it and how does it work? Circuit breaker. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current, typically resulting from an overload or short circuit. Its basic function is to interrupt current flow after a fault is detected. Unlike a fuse, which operates once and then must be replaced, a circuit breaker can be reset, either manually or automatically, to resume normal operation. Construction of circuit breaker, MCB. An MCB embodies complete enclosure in a molded insulating material. This provides mechanically strong and insulated housing. Remaining parts of MCB are: incoming terminal. Incoming terminal is made up of electrolytic copper or silver alloy, and this is where the incoming phase is fixed. Next part is arc chute. Arc chute is a stack of mutually insulated parallel metal plates which divide and cool the arc. Bimetallic strip is part of thermal tripping arrangement, around which a heater coil is wound to create heat depending on the flow of current. Magnetic coil is part of thermal tripping arrangement, where in case of short circuit or heavy overloads, strong magnetic field is produced in the coils. Copper braid connects the moving element with the static element. On-off switch is operator with which we manually interrupt or turn on the electric circuit. In outgoing terminal we connect outgoing phase from circuit breaker. Working principle of circuit breaker. The most important thing that circuit breaker is doing is to safely and reliably switches off electrical circuit during abnormal conditions of the network, that means overload condition as well as faulty condition. Under normal working conditions, circuit breaker work when we switch operator manually from position off to position on. Electric current carrying path shown in animation. First incoming terminal, then contact point of moving and fixed contacts, then magnetic coil, then bimetallic strip, then outgoing terminal. All are arranged in series. Under overload condition, the current through the bimetallic strip causes to raise of the temperature of it. The heat generated within the bimetallic is enough to cause deflection due to thermal expansion of metals. This deflection further releases the trip latch and contacts get separated. The visual indication of this trip can be observed by automatic movement of the operator to off position. In tripping operations, an arc is formed when the contacts start separating. This arc is then forced into arc chute plates, where arc is formed into a series of arcs and at the same time energy extracted and cools it. Closer look how tripping mechanism works.
Residual current device, RCD. What is and how does it work? RCD is protective and life-saving device. It is designed to protect you from an electric shock if you touch phase, live, conductor. A current of 30 mA can be lethal for a person if it persists for more than a fraction of a second. RCD have short break time, response speed, and high sensitivity less than 30 mA. That is why RCD is very important part of an electrical installation. How RCD works. In this scenario, installation is protected only by fuse or MCB, miniature circuit breaker. Fuse protects from overload or short circuit but does not protect from electrical shock. Human body have very high resistance, so if somebody accidentally touch live conductor, very small current will flow off body, about 30 mA. That is not enough to trigger fuse but is lethal for a person. The basic principle that uses RCD is that current in the phase conductor and neutral conductor must be the same. If there is difference, the current must be leaking somewhere, perhaps through a person. RCD compares the current in the live and neutral conductor. If they are not identical, RCD breaks the circuit. RCD compares currents by comparing magnetic fields they produce. If we put a ferromagnetic core, phase and neutral conductor form windings around it, currents flowing in conductors will produce changing magnetic field. The fields are exact the same with opposite directions, so one will cancel the other. In normal circumstances, resultant field will be zero. If somebody touch the live conductor, some current will flow off his body, so current in live wire will be greater than in neutral conductor. This imbalance in currents will produce magnetic field in core. There is a third winding on a ferromagnetic core connected with a relay. Changing magnetic field induces current in this winding, which activates the relay and circuit is disconnected.